Dear students, we have started this new series of giving you video lectures so that you do not waste your time and you get down to real studies. I will be teaching you general science, and I will be first of all covering chapter 6 of your general science book, which is about the structure of an atom. As you all know, that all matter of this universe, be it in this solid state, liquid or gaseous state, or in the form of plants or planets or galaxies, or even the food and the human body, is all composed of matter. And matter, as you know, is composed of atoms. It is the smallest particle of matter which cannot exist independently. It has to form or combine with another atom to form a molecule. Now, what is this thing known as atom? The structure is very simple about it. In the introduction, as you have seen, we have just talked about what is matter and what is it composed of. A simple definition of matter is that which occupies space, offers resistance, and can transfer motion. Atom is composed of atoms. Matter is composed of atoms, which is the smallest particle which cannot exist independently. The structure of an atom is composed of two parts. The first part of an atom is the nucleus, and the second portion is the extranuclear portion, the second part is the extranuclear portion. If I draw a diagrammatically, an atom, the central part of an atom is the nucleus, and around it is the extranuclear portion, the extranuclear portion. The nucleus contains very small particles known as protons and neutrons. Protons and neutrons. Protons are positively charged particles. They are positively charged. They are very small particles, extremely small particles. And a neutron does not have any charge on it, though it has mass equal to a proton. The mass of a proton is equal to the mass of an electron, the mass of a neutron. The electrons revolve around it in the extranuclear portion. They revolve around it in the extranuclear portion, and they are negatively charged particles. They are negatively charged particles. So electrons are negatively charged. The atom on the whole is electrically neutral. Now I repeat again, in the nucleus are the protons and the neutrons, while in the extranuclear portion are the electrons. The protons are in the nucleus, the neutrons are in the nucleus, and the electrons revolve around it in certain orbits known as shells. What is the shell? The shell is the path or the orbit of an electron in which it revolves. That is the path of the electron, the path of revolution of an electron is known as a shell. The shells are numbered as, they are not one cell or two cells, they are numbered as KL, LKL, M, N, O, P. You know, there are a number of shells around the nucleus, and depending upon how heavy or how massive an atom is, the number of shells keep on increasing or decreasing. The number of the electrons in the K shell are 2. In order to find how many electrons are there in a certain shell, we have a very simple formula, 2n squared. If n is the number of the orbit or shell, suppose this is the first shell, this is the second shell, this is the third shell, and then the fourth, fifth, sixth. So these are K, L, M, N, O, P. So if the first shell is there, then the number of electrons in the first shell will be 2. So only 2 electrons can be in a certain shell. So first shell has only 2 electrons. In the second shell, L, which is the second shell of orbit, the number of electrons will be, as per the formula, 2n squared, 2 into 2 squared, 2 into 4 is equal to 8. So in this first cell there are 2 electrons, in the second cell there are 8 electrons, and so on in the third and fourth and fifth we can calculate. Hydrogen is the simplest of all the atoms that we have, and hydrogen has the symbol of hydrogen is H. It has 1 proton in the nucleus, and as many as the number of protons in the nucleus are the number of electrons in the extranuclear portion. So in the first one, if there is 1 proton in the nucleus, then the number of electrons revolving around it is also 1. Carbon, so let's take another example, carbon. The symbol of carbon is C. It has 6 protons in the nucleus, and of course it has 6 neutrons also along with it. So 6 protons in the nucleus, so it has 6 electrons revolving around it, and that is in the second. The maximum number of electrons that can be there in the second shell is 8. So 6 in the second shell and 2 in the first, that becomes 8. Then comes oxygen. Oxygen, you know, has, the symbol is O. It has 8 protons in the nucleus and 8 electrons revolve around it. So they are also distributed, 2 in the first one and 6 in the second one. So these shells are actually the path of the electrons. All matter, whether in solid state or liquid or gas, or as the case would be of a human being or animal, the structure of atom remains the same for everything. And the distribution of electrons is also the same as I have explained to you. Now we come across another term which is normally used in physics or science, you can say, it is about how to denote the atomic numbers. Now this is the topic 6.2 and the atomic number and mass number 6.2. Atomic number and mass number. Suppose you know it is an element. Say we talked about hydrogen, we talked about carbon, and we talked about oxygen. Suppose there is an element. We denote that element as X, and the atomic number is the number of protons in the nucleus. Atomic number is number of protons in the nucleus. So an atomic number is denoted by Z. Atomic number is denoted by Z. So it's a normal practice in science to write the atomic number in the subscript of the element. X is the element, say oxygen or carbon or hydrogen, and the atomic number is Z is noted here. The mass number is another quantity which normally we come across in science, and it is denoted by Z. Mass number is the number of protons and neutrons combinedly is known as mass number in the nucleus. As many as the number of protons and neutrons are there in the nucleus, that becomes the mass number. Mass means the total atomic weight of the element. If X is the element of which we talked about, Z being the atomic number, which means number of protons then A is denoted like this in this superscript of the element, and this atomic number means plus number of protons and neutrons. It's atomic. So atomic number is the number of protons and mass number is the number of protons and neutrons. So A is the number of protons and neutrons, B plus N. So this is how we write. I come again and I try to give you a little revision of what we have done. Coming again, an atom is composed of two parts. The first one being the nucleus, and the second, the extranuclear portion. In the nucleus are protons and neutrons, while in the extranuclear portion are electrons. Electrons are negatively charged particles, protons are positively charged particles, and neutron is a neutral particle with no charge on it. The distribution of electrons in the nucleus is in the extranuclear portion, and they revolve in certain paths. This path is known as the shell of the atom. These shells are numbered as K, L, M, and OP. K being the first shell after the nucleus, L the second and third and so forth. The number of electrons that can be in a certain shell is determined by a formula which is 2n squared, where n stands for the first, second or third shell. So this is the first shell, second, third. So number of electrons in the first shell will be determined by 2 into 1 square is equal to 2. In the second will be 2 into 2 square will be 8. And the third will be 2 into 3 square will be 18. This is the maximum number of electrons that an atom can have in a certain shell. But of course it can have less than 2, less than 8, less than 18 and so on. But the maximum that the number of electrons that can be there in a certain shell is determined by this. Now how best to write this? I've told that X is an element, say carbon, hydrogen or oxygen. Then it is customary, it is a practice to write the atomic number in the subscript, the bottom, and atomic number is the number of protons and number of atomic number is the number of protons, and mass number, which is the number of mass number is the number of protons and neutrons. So A is the atomic, is the mass number, and Z is the atomic number, and which means so in case of carbon, 12 is the mass number and 6 is the atomic number, and this is how we can write C. In place of X we will write C, because now we know that this element is carbon. So carbon has 6 protons in the nucleus and 12 mass number, 6 plus 6 neutrons in the nucleus. So the mass number is this and atomic number is this. This is the practice how we go about it. Now this comes to the second one, and now I'll give you a small home task. You have to write down in your notebooks what is matter, and matter, as I told you, is that which occupies space, offers resistance and can transfer motion. All matter is composed of atoms. An atom is structurally composed of nucleus, extranuclear portion. In the nucleus are the proton and neutron, while in the extranuclear portions are the electrons. The shell is the orbit or path in which the electrons revolve around the nucleus. The number of protons in an atom, in the number of protons in an atom is known as the atomic number, and the number of protons and neutrons is known as the mass number. You will write down this thing in your notebooks, you will make the diagrams, you will talk about the shells, and you will give the distribution of the number of electrons in it and how they're distributed.